Ladies and gentlemen, welcome to my session about practical aspects of persistence and clean architecture. I am Daniel Istvan Buza, and a little bit about me, how I got to this topic and why I am talking about this for you today is that I am a technical lead of 2 development teams. And that means that I'm not only producing source code, but I'm doing a lot of reviews, doing a lot of pair programming sessions, doing technical mentoring. Also, I'm hosting coding dojos. And in all of these situations, I try to make people think about better ways, not just to follow what has been done, I don't know, since 5 years, since 15 years, or even longer, but to actually try to figure out how could we do it better or nicer. And this is a really important aspect of today as well, that I want to encourage you as well, not just to shy away, but if you have any ideas, questions, then feel free to just throw them in. So I do not really necessarily like to host sessions when I'm just talking and everyone is listening or sleeping, but it's a bit better when we have some sort of interaction. That's better for everyone. And yeah, this is a topic which I believe is really interesting. I really like it. And I really like to talk about this particular topic and in general about clean architecture in my dojos as well. But before we start to get into the technical details, my first question is that who encountered the term, at least already, clean architecture? Who knows what that is? That's okay. Who knows what was the first presence on the internet over clean architecture? When did it happen to us? Any ideas or how it happened to us? So what was the first presence?
Robert C. Martin, probably known as Uncle Bob, introduced it.
Yeah, he introduced it. Yeah, exactly. So he wrote in 2008, he wrote a famous blog post, 2012, sorry, a famous blog post, which is this one, where he briefly introduces the concept. And I sort of believe that then, as most of you, if not all of you, are familiar with it, then you probably know so if you would guess, then which part of this blog post I screenshotted in a bit bigger. What would be the core essence of clean architecture? How would you phrase it? Like in one sentence, what's the core of the whole way of thinking about it? What he wants to put into the middle of the focus for us?
Business must not depend on technology.
Exactly, that's a specification of it. But in general, about the dependencies. So this is why I highlighted this, that it's also shown in the original picture, and it's also, by the way, in the book, which was released, I believe, in 2016. But I'm not exactly sure on the dates now. But I can only recommend to read it because that's a really nice book. So yeah. He claims that the dependencies, for example, in layered architecture, are not necessarily helping us because the business core is what represents the value. So if you think about it like this way, if you go to a customer and you say, okay, I have all your database layer, I have your REST API, I have a nice UI for you and whatnot, but I don't have the business logic which is in it, and I'm never going to have it. That's version A. Or version B, that you go and say, yeah, well, I do not really know anything about database, the UI is not even existing yet, but I already have the business logic, and then we can just build up the rest around it. Then it's obvious that which one makes more sense. Obvious that for which one you can get paid for, because what's really important for us is what the business core is doing. So this is where he wants to bring the attention. And he claims that business shouldn't depend on anything. And that also has a really nice implication, because in some cases you can actually try to be a bit extreme on that. And you can say, okay, what does it mean not to depend on anything? Like, should my business even depend on Java itself? Should my business core know about the fact that this is manifested somehow in Java language or in .NET or in Python or whatsoever language you are using? And there the answer could be also no. It shouldn't. You can just have your domain-specific language. For example, in various tax office systems, it is done by that they are actually developing their domain-specific language, and then in that language they are phrasing the tax rules, which I really love, by the way, and I'm sending my likes to every people who are writing those rules every year, more and more complex. But then, yeah, the answer is, yeah, it doesn't even have to know about the programming language. The other aspect of this, that it also has an impact on what you can exchange and who is going to follow if you are changing something. So if you think about it, in a classic layered architecture, if you ever wanted to exchange the database layer, then it's possibly going to make you change a lot of stuff in your business layer, which possibly going to make you change a lot of stuff in your API layer, which possibly going to lead to a lot of changes even on the UI, and that's sort of not good. We don't want to be so hardcore dependent on this. But at this point, I believe it's important to also mention that it's not a really oftenly done task that you have a productive system and you just say, oh, today I'm migrating from Oracle to Mongo or to, I don't know, whatever else database engine. So this is a commonly emphasized fact that clean architecture is also going to help you with this. But I believe for many, many cases, the example is just not good, because you shouldn't think about this as, okay, I'm going to exchange my database engine, because there can be reasons for that. For example, I don't know, licensing model changes, or you are migrating from this provider to another, or you are going from on-prem to cloud, or from cloud to another. So there can be reasons to do that, but that's still not a really commonly executed task. So it's not a daily activity. But what is a daily activity is that you want to run your application locally. And there you can save a lot of extra complexity by being able to say, oh yeah, I just have a couple of local test sets. Then actually a local database, if I am flexible enough, just can be a big hash map. It can handle IDs, it can handle objects. So I can just throw stuff in, I can read stuff out if I am that flexible. As well as it also can enable us to write much better quality tests, because then mocking the database or the whole data layer is just much, much easier. Still, before we get into details, I wanted to also share one thought with you about clean architecture, and especially about the naming in clean architecture, that I assume you also know another famous book of Uncle Bob, The Clean Code, and as well as, by the way, he wrote The Clean Coder as well. And in these two, especially in Clean Code, I would say you don't have to agree with every single rule or heuristic in that book, but it's easy to claim, it's easy to argue for that the better your code or the more your code is following the clean code principles, then probably the better it is. Like I said, I can craft examples against all of the heuristics, but as a generic rule, it's just following clean code rules. It's beneficial. It's really going to lead you to better code. And if you don't follow clean code, then you are probably going to end up at not clean code or dirty code, or like at the end of the day, just a mess of code. The same is, at least in my belief, not applies for clean architecture. So clean architecture is a pattern, which is nice. I personally really like it. And in many, many cases, I find it really beneficial. But I believe it's not that easy to draw the line that everything else, which is not clean architecture, is going to be as unclean or dirty or as bad, so to say, as every other code which is not clean code. At least here the naming is slightly misleading, let's put it this way. So let's get, and I believe this hasn't been really new to you. Let's take a look on my classes. So like I said, we have the business core, whether it's a package or a module or a deployable or whatsoever. Let's don't get into that detail now. because the important part is that it's somewhat encapsulated. Let's say that's a package for now. And then, you know, the one side of the story is really similar as layered architecture. My business core package, it just defines what kind of interface it has or what kind of interface it implements, and everyone else, for example, REST API module, can just call that API or that interface. Easy. Whereas in the other way around, we have a bit of trick, because then in the other way, when my business is using something, for example, a data layer, but this practically can also be applied for everything else, so any outbound adapters, like invoking other REST APIs or SOAP APIs or Kafka or whatsoever, anything that you want to communicate with, then at least in your application, the interface is not going to be defined by the module who is actually doing this task. It's going to be still defined by your business core, which also means that in this construct, your business is not like happy to use an interface that data is providing to it and like really happy that it actually matches the needs. But in this construct, business is sort of defines its requirements, sort of defines its demands, if I want to phrase it like this, that it tells everyone that, okay, if you want to be my data access module, then you must fulfill this contract, then you must implement this interface, which also means that then in this perspective, if you take a look at it, then business core is the lord of both the interfaces. So business is the one who can change it if it wants, but neither data access or the REST API modules can change the contract between these. And this is one of the important aspects of clean architecture. And as the title of the talk also suggests, I want to talk about this one, because it's, as a concept level, it's really easy to get. I have many other arguments for it. I actually argued a lot back and forth for it, against it, in which situation it's better. If you actually encounter a productive code, then there can be really a lot of other concerns that you should or should not factor in. But sort of everyone is forgetting that this is just a concept. You have to somewhat implement it. And in order to have you a bit of sense about what kind of choices you have, I want to define a brief domain that we are going to play around it. So let's say that we have a library. I mean, like not a Java library, but a physical one where you can find books. I hope that people are still remembering that they're existing, like paper and whatnot. And there you can create new book. You can look up books by their ISBN number. You can create readers. You can look them up by name. And you can assign a book to a reader, so he borrows it, and for whatever the reason, mainly because I thought it would be nice to demonstrate that path as well, you can also list the books, like with the titles and the number of pages for every book which is here in this library. It's quite simple. I don't really believe that this is an example that you would encounter in real life, but it's still enough to show a couple of questions, couple of topics around it. So let's say that I want to implement this and I want to have a clean architecture. Then, first idea, what I can do, because Java enables me, so if Java enables me, then I'm going to do that, is just say, I don't really care about objects. I just care about Java standard items that I have. So I can just have such a data access interface that, I can create a new user, I can assign the address to the user, I can get the address for a user, I can assign the phone number, I can get the phone number, and whatsoever. You can just imagine that all the attributes can be set and retrieved by this, and it would work. So an API like this would exactly serve all my goals in this business domain. And I mean, it would be really ugly. So if I would encounter something like this in a code review, then I probably would ask a couple of questions, whether couldn't we somewhat group these concepts a bit more up? But practically it would work. So this is a way one. But like I said, it's not nice if you have more entities, and entities have a lot of lot of attributes, then it really, really fast gets out of hands and just cannot maintain it anymore. But let's not forget that if you have a super small business context, then for reasons that I'm going to return to later, this might be a really, really valid and really good option to use. So let's never forget that only just because we have objects, it doesn't mean that we must use objects. Okay, but then I guess everyone has, like in the head, another idea, which I just call the standard way or the class way. So we can just say, yeah, okay, I'm going to define my business entities as classes. They have the attributes. I don't have the getters and setters, but you can just imagine how they look like. And by the way, Lombok is also generating it for you, so it's just nice. And then my data access could look like this, that this is something that you would encounter in many of the productive projects, that you can save these business entities, you can retrieve them by their IDs, and then, for example, for the books, you can even get all of them because that's needed for that other use case that I just mentioned. And yeah, here what's important to emphasize that this is point one, where many projects just fail to keep clean architecture, because what they start to do is just start to annotate these classes with various JPA annotations, Mongo annotations, whatsoever. And then suddenly, by business core, even I said, no, it shouldn't know about the database. It really should be agnostic. It shouldn't have, so that practically means that in your business code, there should be not a single import in the Java classes which know about environment, which know about, for example, data, how the data is being stored. So yeah, many of the projects just fail. They just annotate it and then bam, they are super dependent on the given database implementation. If they ever want to move away, it's just not gonna happen. Or it's going to be a lot of pain. And the more annotations you have, the more pain it is. So what projects can do, what they actually sort of tend to do, is have a mirror class, which is at least on the source code level technically not related to the actual business entities, but have the same attributes as the actual business entity. And then these classes, because they reside in the data persistence module, then they can have all the annotations, you can have all your extra methods. If you want or if you need, you can have other attributes which help you, for example, foreign keys, private keys, primary keys, and whatsoever. So you can just work as usual. And this is still a clean, not bad solution. And then someone throws in that, hey, this is still, it's a bit boilerplate code. I'm copy-pasting the same objects. Maybe I have a primary key in them, but apart from that, same objects, same relations, and whatnot. So, yeah, let's go and extend them, because why not? I can do that. And then here, in these classes, I can still use a lot of annotations, for example, on the getters and setters, so I can still instrument my underlying database driver to process these classes properly. And many of the projects says, yeah, job done, we are cool. And then they start to actually use it. And that's the next failure that you can do, is like declaring something is done before you start to use it. So only because you have one student who tests it under the fear of being fired and then finds nothing, it doesn't necessarily mean that the project is working properly. Or it doesn't necessarily mean that the project, even if it's working properly, that it's going to work properly in your actual business use case. Does anyone have an idea, for example, what could be a problem with this setup, which in a local test case or even a test environment is not going to cause any issues, but if you start to apply it like in production, if you go to an actual library, then it's going to just explode the whole project. Anyone sees something which could be like that?
Yeah, if you add to the book another property, and then JPA sees the schema of the old database and sees the new schema it needs, and sees a mismatch, then...
Yeah, then it can lead to...
Then it will tell you, use Flyway, regrade it, do it for me.
Or use some sort of database auto-migration tool, or at least create those extra properties. That's true, but even without changing the schema. So yeah, that's true. That if I start to change the schema, then especially this relationship is going to give me some surprises, which can end up in really nice debug sessions. But without changing the schema, still this is sort of a problem, because then just imagine that I want to have the home address of one of my readers. Then I'm going to read this. So I'm going to say, okay, find person by name, where I'm expecting a full-scale person. So I'm expecting all the books to be here which he ever read, which also means that I'm loading these classes which containing all the people who ever read those books. So then this graph just explodes. If I needed only one business entity, it can lead to be sort of the whole database being read in, at least a really significantly huge chunk of this database. And you can, of course, claim that, yeah, it's a really easy example, it's never going to happen. Yes, but in real life, these relationships are not that easy, not that straightforward, and I've actually seen projects which suffered under serious performance problems, mainly because of this, because everything was just eagerly loaded, and then, I don't know, really fetching the easiest attributes had a huge performance impact. So what the developers started to do, they started to write their own CQL queries, like native queries in the middle of the code, because then that's much faster. But if you ever start to change the business entities and you have a lot of CQL queries in the middle of the code, then happy debugging. If you don't have good test coverage, then it's just going to be like randomly popping up. Oh, this feature is broken. Oh, that feature is broken. Oh, that column is not there. Oh, this column is just renamed. So forget it. It's not going to end up well.
It's even worse with cascading. Because there are some situations where you delete one and you actually delete all of your database.
Oh yeah. It's also true that if you are not thinking about this properly, then also, so just imagine that someone forgets a book on a bus where he was reading, and then you just erase the whole database, the entire library. That's it, because we deleted one entity and then you just deleted everything else around it. Yeah, so this yields for something that, like, hey, what could we do better? Like, obviously we know that this is not the end of the story. I'm only talking for 22 minutes. It would be upset if I would just say, yes, guys, that's it. Thank you. See you later. But before we move on, and sorry for all these side quests, but I believe that these are also chunks of info that I really hope that you can reuse later on when you are doing code review or coding yourself or pair programming. Let's introduce a new term, because why not? I can just do that. Let's define sneakiness. And under sneakiness, I personally define, when I'm doing code reviews, something like that you shouldn't do in your code, that you really shouldn't do, but in the meantime, it's hard to spot that you did it. So in this term, for example, using reflections is not some sneaky move, because it's super easy to spot. When I ever see that you are accessing the methods via reflections, then I immediately start to ask questions why it is necessary, why we cannot work our way around it to have a nicer job of way of invoking something or creating something or whatsoever.
Do you mean sneaky throw?
No. I mean, so sneaky throw, I love that feature from Lombok, but I do not really see that as a really sneaky stuff, because it's not really hurting. If you would just anyway throw that exception, or just wrap it in another exception and throw it, or just wrap it into a runtime exception and throw it, then why would it bother if you just write sneaky throws and then that's it, guys. I don't have to write that code. So that's not sneaky. Sneakiness is something which is really hurting you, but you might not spot that immediately. And when you are going to spot it, when it's on prod, especially when it broke something, and when it's going to break something, of course at Christmas. And then you can just debug it. So what I brought is this code. This is sneaky. Do you know why I consider this as being sneaky? Because it actually does what it says. So it removes the duplicates. I mean, like enables only one of the duplicates remaining in the collection. So sort of removes the second, third, fourth elements and whatnot. Given at least that equals is implemented properly, but let's just assume that. Why it's sneaky? Because it takes a list, it gives me a list, duplicates are removed, but the order in this list is not the same as in this list. Because why would it? I just, in the meantime, placed it in a set, which then says, yeah, you don't have a defined order, at least if I just use plain hash sets, then I'm losing the ordering. And this is something which I would not necessarily expect. Even the callers of this method would, so if I would see only this method signature, I wouldn't expect that in the meantime, the order of the elements have been changed, although it's not explicitly written in the method name that remove duplicates but keep the order. So it's sort of enabling me, but this is something that if one of the developers writes and the other just starts to use it, then at some point the other is just going to assume that the first element of this list is still the same as it was, and it's just not going to be.
Even worse, maybe sometimes we'll keep the order, and sometimes
exactly. That's also a really nice property of this stuff, that if you just write, for example, unit test with 1 or 2 elements, then you have a really high chance that the order is going to remain. So it's like time to time fragile, time to time sneaky, but not all the time. And yeah, this is something which we want to avoid. I wouldn't say avoid it by anything you can do, but I would strongly suggest to try to avoid these kind of situations. But like I said, the trick is that they are hard to spot. So when you are reading such a code in a code review, like you have, I don't know, a bunch of files being changed, and deadline is also approaching, so you really have to hurry up, then you might not going to really think about the details, like, hey, is it used in a context when it really doesn't matter that the order changed. But what can you do? Easy. You can just say, yeah, I'm going to change the implementation, the same signature. I'm just going over the input, place it into a stream, because why not? It's so sexy. I just say this thing and toList. It works, and then this preserves the original order. So
But because this list is unmodifiable, right?
Exactly. This is why that's also sneaky, because now suddenly I cannot change this list anymore. So it's also something that you spotted, but I'm not exactly sure that every single developer would spot it that straightforward, that in the meantime, this is also not necessarily exactly what you would expect from such stuff.
it's also not necessarily bad. Maybe I want my list to be...
Yeah, it can be. So it can be that you are wrapping it to an unmodifiable list anyway, or you are just, I don't know, serializing it and giving it to an interface partner, or showing it on the UI, or what. So there can be many applications where that is not even like it still remains sneaky, but it's not really hurting you, so it's not going to cause you any problems. But still, if you go in this direction, then I would say you can just never know, because if a developer writes this method knowingly that, okay, this is going to give me an unmodifiable stuff, and actually uses it in a manner that, for example, it only pushes some data to the front end, it's not causing any harm. But at some point, another developer is just going to say, oh, this method is already there, I'm just going to use it because it's already implemented. And it's really hard to ensure that that next developer and the over next developer and the next guy after that is always going to know this, that, hey, this is sort of changing, or not only removing the duplicates, but changing the list in another aspect. Why I was talking about this, first of all, because just like to share the idea of sneaky problems of people, because these are something that we really should look out for. But also, let's jump back a bit to this concept that we had our business entities and our data entities, and then the data entities may or may not extending the business entities. Now it's two slightly different concepts, but the problems are going to remain really similar, and there are a couple of sneaky problems around that, which, like I said, might apply to your project, not necessarily. So it's not like that every single project have these problems, but you have a good likelihood that it will. For example, it's not that straightforward in this case how equality works. I mean, like, of course, the data entities, they know about the business entities, so they can implement equals in an adequate way. But in the other way around, if you just simply have normal equals, for example, generated by Lombok, it's going to check the class. And then it might say, oh, it's not the same. This instance is not an instance of the same class. It's not equaling, so I just know that it cannot be. Then it can lead to really tricky constellations. Even if you say, yeah, okay, I'm going to equal by the attributes, but the data entities are also introducing new attributes because they are needed for some database maintenance stuff. Like you need extra attributes for indexing, for searching and whatnot. Then suddenly this equality is a bit not that straightforward stuff. And just remember that in the previous slide I just said as a by the way fact that, oh yeah, here we are taking advantage that this class, that this has a proper equals, because otherwise it wouldn't work with the sets and whatnot. So, or actually in the first case it wouldn't work without proper hash code, but that's not the problem here. So yeah, equality can be a tricky problem in this construct. The other is that if I just check the graph of my business entities, then suddenly it's going to be really colorful because I have my business entities for sure, but I also have a lot of database entities. And if I have, for example, multiple data packages, because why not? I can use one for, I don't know, production, which is optimized as hell and works on, I don't know, one sort of database, and one for some test environment, and one for my unit tests, and the fourth one for my local setup. Then I'm just going to end up with a bunch of classes, which might or might not be business relevant. And if in my actual business model I also have inheritance, then it can be really nice to somewhat spot, okay, which class is still belonging to my business domain, which class is, again, not in my business domain, just for the data access layer. And by the way, also, the creation of the business class instances is getting a bit more interesting, like how an instance is born, because then partially in your code, or at least you have a high likelihood that in your code at some point you are creating the instances of the business entities, like you are creating a new reader or a new book in this domain example. But in the meantime, your data layer also creates instances of those classes, or at least subclasses of those classes, or even if they're not extending then actually instances of those classes. And it's like, so if you are interested in, okay, how a new book can be created, then you suddenly going to find actual business creation ways and such ways which are sort of like technical creation ways. So like after persisting, how I can retrieve them from my data layer. And this is also, like I said, in such a small example, might not be a big issue, but if you scale it up, then at some point it's not necessarily lucky that you have no clue how your business entities are created. And extension especially brings also the option to me that I can sort of change the behavior of my business classes. So if I'm extending them, then everything which is not final, of course, can be changed. And for that, I also have an example why that can be a problem. So just imagine that still we are working with the library. And once I can say that, okay, a couple of attributes are GDPR protected. Like, okay, for a book, it's an open info how many pages it has, but it can be a bit more protective info whoever read that book, because I might not be able to just give this info away. So, and then this is described, for example, in a nice user story, because we are living in an agile world, and then someone just goes ahead and implements this. And it says that, okay, whenever you are accessing the readers of the book, first I'm checking that the current user has admin rights. Let's forget how that works, but just imagine for the example. And if not, then I'm throwing an exception. And this ensures that from this class, without admin rights, you are not going to have the readers. Not a chance. It's super straightforward, super easy to test, super easy to understand. So it's something that I would say, yeah, I approve it. Nice. It works. And it also nicely groups it up. So this actually ensures that as this is private, that I'm accessing it via this getter. So it's really, even for the already existing features, it's ensuring that this new business rule is going to be applied. So it's nice. Let's do it. In the meantime, someone else also says, yes, guys, it's cool, but we have a bit of performance problems. Cannot we just apply lazy loading, for example, on the readers of the book? Because I might not going to need them. And if yes, then they should be fetched from the database, but otherwise it shouldn't be fetched immediately. So someone else goes and in the book database entity, which still extends book, just defines get readers as this. Because why not? Because then here you can just say, oh, if the readers are not loaded, then I'm loading them. If they're there, then I'm just returning them. I made a mistake in the meantime because then this, of course, should be protected because otherwise you cannot do this trick. But who cares? I'm just going to go ahead and change the private to protected like there is no tomorrow. No one can stop me. And in this case, what is happening is that you are losing this feature. I mean, partially using this feature. If you have an instance which is created in your business core, like you are creating a brand new book instance, then of course that's going to have that method. But if you are loading a book from the database, then you don't have that method. Then you are not going to have that. So you are losing it. And why it can be super weird is that, first of all, if you have the right timings, then this appears just a little bit later as that one. But when you test this, you are never going to just play around, oh, by the way, what happens if I don't have the admin rights? Because all the test users, of course, have all the rights. Because why not? And in the meantime, your unit tests are going to be green. Because this code is tested in your business core. In your business core unit tests. So, there you are going to create instances of that class. But in real life, you are creating instances of this one. Which is just so nice. I mean, losing a feature so that all the tests are green and not that easy to spot. It's just elegant. It's sneaky, but you have to admit that it's sneaky in an elegant way. Although, I don't know whether that's a proper description. And of course, what you can say, oh yeah, but this method could just invoke super get readers and then I could just chain these effects onto each other and whatnot, so it could do that. And then there's the business. He could define, for example, this as private, although for a couple of database implementations, you at least have to have them as protected. But at least what I can do is mark this method as final, so this cannot overwrite it, and then it's just going to happen. Although, just play around with the thought, if this is final, then suddenly having a lazy loading manually implemented is not that straightforward, because then you don't have a really good entry point when you want to fetch these entities, or at least you have to implement some person bridges which are then aware when they are going to be used. So that is not that straightforward to see where to inject my lazy loading logic. But that's only the technical perspective, so we can do it. But what it means, if you step a couple of steps back, that on a bit deeper level, suddenly your business is starting to, who is, like we said at the beginning, who is the lord of this whole data interface. So business is the one who defines what happens and what not happens. If you start to have their final methods, then your business starts to treat the data module as a hostile module. So something which is not friendly, something which, if I'm not aware enough, then maybe it's going to change my business rules. So then that business starts to prepare itself like a bit of paranoid to, okay, what happens if my data access is going to change my method? So then it can be a good argument, for example, this, to say, okay, everything in business is final. And then it's just like, it would work, but it sort of gives a bad feeling. So it should be like business is trusting. So if business defines that interface, that business should be able to trust what data access is doing. Otherwise, we are just enemy to each other. And yeah, what else can we do? So I believe that you are already familiar with this concept, and there are many, many other tips and tricks, because this concept is evolving since decades now, and we have a lot of stuff that we figured out how can we improve this situation from the performance perspective, from the code perspective, from the architecture perspective. So there are many small improvements applied to that, but there are some core issues which are still happening. So you cannot say, oh yeah, I never seen a modern project with this lazy loading, lazy versus eagerly loading problems, because it just happens again and again. Then we can just step a bit back. So let's say, okay, this is a way which works, but what was my starting point? My starting point was, besides clean architecture, that this works. And all the problems that I just mentioned are not applying to this one, because here I have no classes, no inheritance. I cannot overwrite anything in string because it's just final. So this would not enable my data layer to do any sneakiness in this. I mean, of course, apart from not giving me the same data back. So I have to trust it that if I'm setting, for example, for this user, this phone number, then next time that I'm accessing it, I'm going to return the same. So I have to trust it that it gives me the same data, but no other sneakiness can be in this game. But it's still not good. So we just know that we don't, so like, honestly, we don't want such stuff. No one wants to have such classes, at least if you have a bigger model. What else you could do and that you can utilize is interfaces. Because in Java we have interfaces. Why not use them? At least why not play around with the thought whether we could use them? And here a sort of sneaky question from me. Does anyone here knows what does the Java language specification states about interfaces? What's their purpose? So like they are used, they meant to be used as papapam, or you should use interfaces for this, that. What does Java specification tell us about it? Anyone has an idea? So I even didn't know before I just actually looked it up in section 9. But do you have a feeling on this? Because that's also a question that we are discussing. For example, in pair programming sessions, like what's an interface, what's an abstract class, what are the, how to decide which one to use. So do you have a feeling on what was the original intention of Java?
The joke
language creator.
The joke or the new one? Basically, I deal with this as a contract between everyone that relies on that contract to work together and expect that behavior. And this allows you, doesn't care about the time, but you are going to have that method every time you inject that dependency.
Wow, yeah, that last half sentence about being injected for the dependencies, this can be a bit tricky, but yes, this is the common understanding on interfaces, but that's not this is not what is in the Java language specification. Because, yes.
Maybe it's Java's compromise for not offering multiple inheritance. Probably
yeah.
The language specification, but this is effectively what it does in real life.
Yes and no. So yes, this is what we do in real life, but this is in the language specification. What is not in the language specification is what's the purpose. It has no statement around it. It just states what you can do with it. How can you use it? How can you declare interfaces? What are the attributes of it? But it says not a single word about when to use them or what's the purpose. It just says, as the colleague actually said, that yeah, you can interfaces can be implemented by one or more classes, and later on it also states that the same class can implement multiple interfaces, of course, so like the other way around. And the programs can use, but it doesn't say they should use, they just can use it. Can use interfaces to provide a common supertype for otherwise unrelated classes. Makes sense. And to make it unnecessary for related classes to share the common abstract superclass. That's it. And then starts the actual specification, like how to do it, what are the keywords and whatnot. And this at least not holding me back from playing with the idea. So if it would have stated something like, hey, please don't use interfaces for this and that, then I would probably say, yeah, okay, then I should stop. They are probably right. But I can do it. What I can do is just saying, oh yeah, like using them as a contract, saying that actually what I'm retrieving from for example, from my database, because as you could see that many of the problems are not really evolving around saving stuff into database. There can be also a couple of tricks, but mainly it evolves around what I'm going to get back and how I'm fetching the data from the database. So I can say, yeah, actually, I can just define what methods it should have. Because then what I know about, for example, a book, that it has a title, it has an ISBN, it has number of pages, and it has readers. So
maybe
yes?
Just to introduce multiple inheritance, but not the C++ way, where you get all the problems with the deadly stylement and virtual methods and so on, and they wanted to simplify it. That's why I think they said, well, let's keep the signatures. And
yeah, although this way of thinking is sort of broken by the fact that we can have default implementations now in Interf. So then they are really tending to look alike like C++ multi-inheritance, although I know that under the hood it's not the same, but it sort of gives the same vibes. But then in our business model, we can just do this, because why not? I can say that I have a couple of has this and that interfaces, and the book can, which is also, it's an interface, because why not? But it can be a class as well. It just can extend it. And the other also. And this is an idea which I believe it would surprise a couple of developers. So if you just open up a code and you find this, then you will probably going to use a famous 3-letter abbreviation for asking what was the thought behind this. Maybe a bit less politely. But if you think about this, in many cases you can just use this. I mean, like, it would work. If I'm defining everything that I want to use, then I can do that. I mean, pretty much straightforwardly. And then it also means that business can define it way more precisely what it needs. So instead of having this, hey, give me all the books so I can read the number of pages in the title, now I can have such a method where I define exactly that I don't care about the readers, I don't care about the ISBN numbers, I just want a list of something which I don't know what it is, but every single element must have a title and must have a number of pages. With this, I can already print out my list of all the books with how long they are. And that enables me to sort of stop this guessing game that in the other version data access is doing. So in the other version data access is trying to guess, okay, are you going to read this attribute or I can lazy load it? Because in some cases, lazy loading is actually a bad option because it's going to be slower as actually eagerly loading with the same query all the attributes. So then you can specify it way more precisely to your data module that, okay, for this, when I'm calling that method, I'm just needing these attributes. I don't care about the others. You can load them if you want, but you don't have to if you don't want. I don't care. What I care is that give me these. And this also gives me a different sense of thinking about the classes, because here still I can pull a couple of tricks with how I implement these interfaces for sure. I cannot prevent it. So if someone really wants to be a bad guy, then you can implement a data module in a way that it's not really going to help you in business cases. But at least when you are reading the business code, when you are dealing with it, then you know that you know that what you are getting back is not going to be, or at least with a really high probability, it's not going to be your business. It's not going to be an instance of your business class. So it gives you already like a bit of vibes. I wouldn't say I would never think about it, but it's just way more likely that when I see an interface, then I start to think about it when I'm reviewing that, okay, who is implementing this? How it is implemented? How many implementations do I have? Are they really exchangeable? So are they really fulfilling the same contract? And if yes, then why they actually exist? Because then if they actually do the same, then why they exist or why they coexist. Whereas at simple classes, it's not necessarily my first question, oh, is this class extended by someone else who might override this method? Whereas in interfaces, it's just a more natural, more straightforward way that you are thinking about it, whether or how they are implemented. And also, it gives the possibility to actually improve a little bit the business flows as well. Because we actually talked about it, what happens if I'm adding a new attribute to a business entity? Well, if in the other way, in the class way, so let's say that this is the interface way and that was the class way, if in that way, suddenly a business entity gets a new attribute, then everyone who had anything to do, like each method which gets an instance of that class, sees that new attribute as well. Can call the getter, can even call the setter, probably, and can do whatever it wants. With this construct, I can also limit that, because if I go ahead, I can have such a construct that I can say, oh, this is my main flow, invoked by someone, and this is fetching from the database. But this method, it's not really knowing what it gets, it just knows that, hey, this is going to have a title, an ISBN, and readers. And this even have even less knowledge, it just knows it has a title and it has an ISBN. With this way, if the book gets a new attribute, these methods are not going to access it. They are not going to have a normal way, of course, I know, reflection, you can do it, but like a way which is just straightforward, they cannot access it. And it also means that if suddenly I just decide, oh, this method, it actually needs the number of pages of the book as well, for whatever, because I want to log it or I want to do something with it, then I have to change the signature of this method, and potentially, although here I was a bit lazy to actually define it properly, but probably also this method. And you can say that, but that's a bad thing, because then in the class way, I can just add it to the book and use it here, easy, 2 places in the code being changed. With this, it's potentially leading through many methods, a lot of signatures being changed and whatnot. But I would argue, again, that this is not necessarily, out of the box, a bad thing to do. Because then, when I'm reading your change, when I'm reviewing your pull request, then I'm going to be aware that, okay, where? So like adding a new attribute impacts exactly which code. And then I can actually actively think about, do I really want this method to know about that? Do I really want to know this method about that? So I can actually think about it, whether it's still a correct business flow, what I'm having. And this can lead me to say, oh, but then that logic that you have with the pages shouldn't be here. It should be like here. Or this method should invoke something else, which knows only about the number of pages. So it can lead the developers to realize that they are not necessarily doing it the right way. Like I said, it's not necessarily going to lead to this, but it can be a useful way to realize this stuff. And also just imagine that you have, so like still it's a super minimal model that we have. But imagine that you have a lot of stuff here. Like, I don't know, you are having a lot of T1, T2, T3, until I don't know, T10 even, and with randomly a lot of has this, has that interfaces. Then this at some point is going to scream at you that this method is sort of not good. This method is sort of knows too much stuff. It's also bringing the argument from clean code, do one thing. If you have a lot of has this, has that in your method signature, then it clearly says that, okay, then that method is not doing one thing. It's doing multiple stuff, or you have some super complex operation, which is one thing, but then it can also help you to realize that when you reach the part that the method knows too many stuff, and it does too many stuff. And the side note on this still is that what you can do, because this is a sort of extreme example that I just had for every single attribute a new interface to get it. And if I really wanted to, I could have for the setter separate interfaces because why not? I can have, so like this, has that, they are just the getters, but I could have the setters, why not? No one stops me, the compiler is going to compile it. What you still could do is group these getters up a bit. So for example, you can say, okay, on a complex entity, I have a couple of attributes which are, I don't know, like production relevant, and a couple of entities which are, I don't know, logistic relevant, and a couple of other entities which are somewhat GDPR relevant. Then at least you can have these three interfaces, and then at least you can ensure that if, for example, this method only knows about the production attributes, then if someone just says, oh, production attributes, and by the way, GDPR attributes as well, then at least you will see, hey, this method is sort of start to breach some sort of borders that it maybe shouldn't. So if you just don't go and blindly do this, like every single attribute, a new interface, then you can nicely define like business areas within your code as well. Like who should know about what. Yes?
Don't you need to cast all the time between has title, has ISBN, has readers when you want to access them?
No.
Casting all the time.
No, you don't have to cast it. So if you declare that here this has title, has ISBN, has readers, then on this you can just call the get title, get ISBN, get readers without casting.
If they share the same property, different interfaces share the same method, then you need to cast.
Yeah, of course, if you reuse them. And by the way, it also opens up the possibility that you can craft such like definitions here that do not even exist. So I can just write, I don't know, has phone number, has number of pages. Because why not? It's still going to be allowed. So compiler is going to compile it, and it's not going to notice that, hey, those are attributes of different business entities. But on the sunny side of this stuff, you also can think about it whether a business entity is having the same type of attributes or something different. So then you can ask whether, I don't know, like a company, like the address or post address of the company, is it really the same type as the post address of a person or not? And if it's yes, then you might just going to reuse the same interface. It's not, then you might use something else. So this is giving you a bit more sense over what attributes are sharing the same type way better as, for example, just using string everywhere or just the same Java primitive, because then you are going to have some unexpected surprises.
And just to reinforce, like these interfaces, they are the minimal methods that should exist. So
yeah. So exactly.
And different ones could not have like the name attribute, but others could be if they implement the same.
They can actually have the method. So even if they don't implement the interface, they might have it, but then I cannot use them here. So then in order to invoke this method, I have to provide an instance which at least implements these two. Yeah, exactly. And of course here, if I do it smart, then here I can just list what I actually really want in this method. But it also gives me a sense of what this method is doing. So this is also something which I believe heavily underrated, like to strive for such a method signature that even without checking the method body, you can sort of guess it right what it is doing. And then if you know exactly which attributes are going to be accessed, then you might have a better chance as if this is just book here, and that's just a void. And it does something with the book. I have no clue. At least I know that what kind of attributes is going to be accessed here. And yeah, I wanted to sum it up, but I don't want to reiterate over everything that I just said. So for my individual view, I selected a couple of bad and good sides of this. What I feel like a really bad stuff, apart from the sneakiness, is that that business has to defend itself in the class way against everyone who is implementing its interfaces, and that just gives me bad feelings. It's not going to end well, and data access can do a lot of sneakiness. Although it's true that this way also works well in many of the cases, and we are really well prepared for that. We know that pattern for decades, I believe for all the simple problems, there are out-of-the-box solutions like industry standards, best practices. You are not going to surprise your developers with that. Whereas this, the interface way, of course, you can end up with many, many interfaces. So just like I said, if you start to have all the attributes and then you start to group them up and then your business entities are also going to randomly have them, then suddenly you are dealing with, I don't know, dozens, even hundreds, maybe thousands of interfaces, which at some point I'm not convinced that that leads to a better readability of your overall code. Let's put it this way. And what I see as a really, really bad point on this, that's unexpected. So I would say an average developer is not going to assume that this is how you are using these interfaces, which also has some not necessarily technical but team aspects as well. So whenever someone new joins your team and then looks at your code, then you first have to clarify what is happening here. Also, it's not that hard, so you can just share the base concept like in 1 hour or even faster, I believe, if you don't get into all the details. And I know that this is a strong force not to do this, but still, I would also argue that with that argument, we wouldn't move forward, because using lambdas was totally unexpected before Java 8. So then you could argue, oh, let's just don't use them, because every developer who are socialized on the previous versions of Java, then they are going to be surprised by that. So it can be a valid argument, but that sort of freezes you in. And what I see personally as a really big positive on this is that it gives you a way stronger, an option to define way stronger what each method can access, how the methods are going to be, and this is going to yield to you that if something is just doing many stuff or it's breaking its barriers, then you will just see it much, much faster in the code as with the old way. And yeah, with that being said, I hope that you enjoyed the session. And my last sentence would be not directly related to clean architecture, not even for this interface magic that we can do, but as a general, if you don't take anything with you from today, just one stuff, then it should be like this, that you should always look for other ways. Don't do something just because we are doing that since 5 years, since 10 years, since 15 years. Think about new ways. They might be bad. Then it is how it is. Then you just found a way which is not practicable, but which is not practically applicable. But always strive for new ideas. Try them out. Have, I don't know, a couple of hours every week when you are just playing around these thoughts. Because if you have this mindset, then you can discover many, many areas of the language, many ways. Amongst these ways, many bad ways. So when I'm playing with my thoughts, then after a couple of hours, I just have to realize time to time, oh yeah, this is why people are not doing this. Okay, now I get it. But at least I got to the same point. And if you don't find any strong argument against doing something, then let's try. Let's do it. I probably wouldn't apply my newest ideas to some, I don't know, really high critical project which is controlling, I don't know, critical infrastructure. So take it with a grain of salt, but only that something is new, I believe, shouldn't hold us back from using it. And yeah, now I'm thanking your attention, and yeah, let's share your thoughts. If you have any questions, ideas, anything else to add here, then that's the time.
Show us the code of this project implemented with this concept.
Yeah, I can actually show it to you. Not now, because I don't believe that I have a network connection, but if you find me on LinkedIn, then you will find my private GitHub repo where I actually have the example code for all of this and for other projects as well.
Will you send me the link? Then I put it to our homepage and you will find it there.
Sure, we can do that. Yes.
In the company I was previously working, 2 team leads had a discussion. One wanted to give as a function input only big objects, and one wanted to give every single piece of information into the function, which is like the interfaces, has title, has number, etc. And he argued, okay, when we do this, we realize, okay, this function has 5 things, which it manipulates or which reads, and then we know, okay, this function does a lot. And we try to do that, but we try to implement it this way in a few months. But we realized, okay, oftentimes we need all these information, and then, okay, if the function has more than 5 parameters, we use an object. So, like book extends, has title, etc. Interface. So, I think oftentimes in practice we really break a lot. Don't modify, just extend when you are extending classes and interfaces. So I'm not really sure if just in the end the developers will just say, okay, I have this meter interface or the super interface which extends all the other interfaces, which includes in some way other interfaces. That was my experience from real-world application.
Yeah, that sort of relates to like the old question, how many parameters a method should have. Because then, of course, there's a straightforward response to say, oh, I have too many, I'm just grouping up into an object, and then, bam, I just have one input parameter, which still holds many other stuff, but then I just have one. I don't believe that there is one superior way, like doing one way, so we'll have like, I don't know, 5, 6, 7, 8, I don't know how many input parameters versus having one object which groups up all of those. Because in some cases one could be better, in some cases another could be better. What I would strongly argue is having an object is sort of more readable in most of the cases, because then you are not going to end up at a situation that you are just, for example, if you have 8 string attributes, 8 string input parameters, then you can just flip 2 of them, everything is going to compile, and still it's not going to work properly. If you have only one object, then at least if you call the setters, then it's way less likely that you are going to unwillingly swap parameters there. So that's at least one advantage, that it's a bit less likely. The other, what I would suggest to do is at least use records, because then you cannot change that object. Because what this object way enables you that you pass an object which holds, I don't know, 5, 6 attributes together, and then that method which has it as an input might going to change these attributes. If they are not final and it can access those attributes, then you cannot know whether that's going to be changed, and this changed instance is going to be passed down to further methods, or after the method invocation in your main method you also have this change instance. So it can also again lead to some sneaky stuff that you can do and hard to realize, and maybe also seems to be a good idea. So what happens often that in the method which gets this object, you want to invoke another method and want to pass the same object but slightly differently, so you change it, and you just don't think about it that, okay, then the method who called me after invoking me going to have a different data in its hand. So this is what you don't necessarily realize immediately. So yeah, I would go for records for sure, because then at least it's stone written. You cannot do these kind of tricks.
And the other thing to reduce this case you expand, it's like in your example where you're extending the types and generics. Like 3, it's already too much. So you can create another interface that implements, that extends those three.
Yeah.
And then you just have one now.
Yeah.
So like your signature, it's shorter and it's easier to read, and it's still open to extension.
Yeah, it's true. So
do that. It's the same thing like the example you gave in the book, where you throw up an exception. Like that you can create an interface for that thing, like can access gRPD data. Like
yeah. So then you can still remain really flexible, but
interface said you like, if not, throw this exception.
But what I would also bring the attention to is that here we are sort of start to mix up like coding concerns and application architectural concerns. So like how my interfaces should be laid out, what kind of classes do I have and stuff and whatnot, then that's sort of a different area to tackle as like, okay, how can I write this method in a way that it's easy to invoke, easy to use, easy to test and whatnot. So then we are sort of getting to the border of these two stuff, which I would strongly suggest to keep it clean. So whenever you have input, so like whenever you have an object which is only there to invoke a method or a couple of methods, then at least somewhat place it near to those methods, maybe in the same class or in the same interface. So like make it transparent that this object is not to be used everywhere in the code. It's strictly meant to be used for this method. Of course, you cannot really force people not to use it. If it's public, then they're just going to use it in the most unexpected ways. Yeah, as long as it's public, then they're just going to do, so you cannot really enforce this rule, but at least you can give the hint that, hey, this object belongs to this class, so it's like an inner class of that, and then it's at least, it gives me bad vibes if somewhere else it's just going to be used for some other purpose. Although what I see I wouldn't say often, but I've seen it in multiple projects, is like reusing the key value pair of hash map. That's an internal class, and practically you can use it whenever you want to store a key value pair. And if you are too lazy to declare, for example, a record with it, then you can just use that class, which is bad. Don't do that. It's not meant for that. It's meant only in that context. I do not really exactly know why that's public. But probably because you can iterate over it. Yes?
What's your experience with DTOs? Have you ever used them?
You mean DTOs? So like...
Data transfer.
Yeah, they are there. In many interfaces, many APIs, you cannot really not use them. I mean, of course, you can argue that, I'm just going to expose my business entities, but I can craft really nice examples why it's not necessarily good stuff. So yeah, you just have them. I don't feel like they are good or bad. They're just some necessarily around APIs to have them. At least in many cases. Of course, you can, if you really want to, you can just go for like map object, and that's everything. You can deserialize any JSON to a map object. Good luck, have fun. Going to be really super readable code.
It's like if we use DTOs, I use them a lot already. You start to having a lot of data transformation, because the DTO is supposed to be sneaky, like not sneaky but skin. And every time you need to go from one side to another, then you'll have like a person to dog transformer.
I know.
Yeah.
Then there were smart people telling you, don't repeat yourself. You have not understood if you use DTOs.
It's just
yes, but
another like philosophy. It's like
I would counter that argument with other smart people also say that, like Uncle Bob, that there are actual duplicates and false duplicates. And this is, for example, an example of false duplicates where the code actually looks like the other code, but it has different reasons to change. So it's not a duplicate. So you should reuse code only in a context when you are sure that so when you encounter two objects which are always going to be changed because of the same reason at the same time, then it makes sense to say, okay, I'm not going to use 2, I'm just going to use 1, and I'm reusing it. But if you have 2 objects which are really similar to each other, but there might be a time or there might be something which leads you to change only one of them, then it can be a really bad tactic to introduce 1 instead of these 2, because then suddenly you don't have this option to change only for 1 flow. So but at some point it starts to be more theoretical, and at some point it's going to be more religious question. So I don't see for these constructs one is ultimately better as the other. It's really, so I'm sorry for this answer, but it's really context dependent. Like, show me the code and then I will give you an opinion. But yeah, you can do. This is why Java is just so nice, that you can do many stuff. I mean, most of them are bad idea, but you can do them, and it's going to compile, it's going to work at least until some point. Yeah. Anything else to add? Yes.
So I'm curious if do you put that into use in real projects with a large number of people? Because I would like to know how people adopt to that kind of approach.
That's also something I would really love to see, because no, I haven't put it in a project where we have large number of people. I tried it out in a project where we have small number of people. And then as the group wasn't changing rapidly, so I just had to introduce this concept once, and then everyone was up to date with it, and then we could use it. But I really don't know. So like then, if you think about this, then the idea was onboard it to a group of people. But I have no experience with that, like how to onboard a new person to this idea, so into a context where this already is in place. But I'm looking forward to do it. So it's like, you can say, oh, that's bad, that's some bad thing. But at least I'm not the only one crazy person around there who plays with this idea. So there are other articles on how can you do this and what you can group up, and people are really playing with these ideas, which might going to die out in a couple of years, I don't know. But at least I know that it's worth think about it.
I use it with this crazy interface stuff, but it helps for sure, because it's help you to create tests. And every time you extend, like let's say you extend an interface and put a new method, your own tests are going to work before you build. And then you can like go to each one, your own IDE helps that, like you go to that interface and search for everyone that implements that thing, and then you can extend all of them. So it helps, but like if you are receiving a new person that never works with interface before, it's going to take time until like he trusts in this different standard of doing. But to me, it was nice. It was a good experience.
See?
So it depends on both of your experience. How was the data model? It was a small data model, as you said that it's a small group.
Yeah, it's rather a smaller, so a bit bigger as this example, but I would still consider it as some overseeable. So I don't know the exact number of entities, but a couple of dozens. So like not many entities, and also like with mostly pretty straightforward relations between them. So I sort of guess that the more the entities you have and more complex they are relating to each other, then probably you are going to encounter such problems that I do not even aware of because of the simplicity of these use cases. So
I was thinking about this composition of the, you said that has the phone number, has the address and things. Then developers start to make the composite interfaces from that something that has the phone number. And if the number of these is so much, after a while you will find lots of interfaces that are same to each other. And it's hard to consider a team with the 100 person working, and each one of them is trying to make an entity for himself.
So we'll end up at, this is why many is italic here. It's like really many of interfaces.
Even if it become a chaos, it's cheap to remove it. Like, because these entities, they are implementing these interfaces. So it's not like you go for a class and rip out a attribute. that will be a cause. But if it's an interface, like it's a mesh, let's say you have thousands or duplicate interfaces, you don't use them anymore, you can just put them off, and that will be like less dangerous to refactor. If you consider, like, imagine you have 4 lines of extents, class 1 extent, class 2, class 3. You cannot go to the class 2 and remove the class 2 because you're going to break down the next extents. But with interface, you can like compress them or expand and then re-implement. The price of changing it will going to be lower.
And to be
it should be polluted. I mean, sometimes we need to somehow be aware that what is going on. And I imagine, for example, in the project that I am working now, it would be.
Yeah.
It would be actually a lake, or let's say the ocean of interfaces.
Yeah, so many means really many of them, but I believe that the source of doing something wrong with this mainly would be if someone is not aware or not understood the concept behind it. So this is still, so like as you said, yeah, if everyone is up to date with it, then I believe it can be really sustainable. But if someone is not and starts to randomly introduce these new interfaces, then I believe you can. So this is also not going to protect you from writing a mess. It's just another way that how you can potentially write some nice code as well. But
you know, it's like people say with medicine. The difference between medicine and poison is the amount you take. So use it carefully.
Yeah, so take it with a grain of salt. But if you have the chance, at least try this and try everything else, or at least think about trying new stuff. Then, thank you for your attention. And hopefully we see each other in 2 weeks when I have another session about some other lessons learned.